All right, let's talk Java. If you're a B.Tech student, you know that dealing with data is everything. So today, we're opening up one of the most powerful toolboxes in Java, the collections framework. This is going to change how you handle groups of objects, making your code cleaner, faster, and just better. Let's dive in.
So let's start with a really basic question. It's probably one of the first things you ever had to figure out. You've got a bunch of student roll numbers or a list of scores, a group of anything. What's the first tool you reach for to store them?
Yep, of course, it's an array. We all start there, right? It's simple, it's straightforward, and for a fixed number of things, it gets the job done. It feels safe and predictable.
And here's where the problem always starts. Because in the real world, things are rarely fixed. What if a new student joins, or someone drops out? Suddenly, that simple array becomes a real pain in the neck. You're stuck. So what do?
The truth is, for most real-world coding challenges, arrays just don't cut it. They have some serious limitations that can create a lot of extra work for you. Let's get specific about why they often fall short. So there are three big headaches. First, that fixed size. It's like a box that can only hold exactly 10 things. No more, no less. It's totally inflexible. Second, if you want to add or remove something from the middle, you have to manually shift every single element that comes after it. And finally, arrays are kind of dumb. They don't have any cool built-in powers. You want to sort it? You got to write that code yourself. There has to be a better way, right?
And of course there is. This is where Java comes to the rescue with its collections framework. This isn't just one little feature. It's a whole system, a whole new toolbox, designed specifically to solve all those array problems.
Now that definition sounds a little formal, but here's what it really means. The collections framework is a set of pre-built, super efficient data structures. It's a collection of tools, all ready to go, waiting for you right inside the java.util package. No more building from scratch.
So at the very top of this whole system, you've got the collection interface. And from there, it splits into two main paths you need to know: list and set. A list is all about order. Just like your class attendance register, the sequence you put things in matters. And hey, if two students have the same name, that's totally fine. But a set is all about being unique. Think of it like the roll numbers for your final exam. No duplicates allowed, period.
Okay, knowing the blueprints is one thing, but being a good programmer means picking the right tool for the specific job you're doing. And your choice between a list and a set is a big one. It's going to define how your data behaves.
Let's break it down side by side. A list keeps everything in the exact order you added it. It welcomes duplicates, and you can grab any item by its position, its index, just like an array. A set is the total opposite. It makes absolutely no promises about order. It will automatically reject any duplicates you try to add. And there's no such thing as an index. You can't ask a set for the third item.
So, list and set are the ideas, the blueprints, but you don't write code with an idea, you write code with a concrete tool. So now we need to pick an actual class that brings these blueprints to life.
The two you're going to use most of the time are ArrayList and HashSet. ArrayList is the most popular type of list. You can think of it as a superpowered array that can grow and shrink whenever you want. And HashSet is your go-to set. It's incredibly fast, using some clever magic called a hash table to instantly check if an item already exists.
Okay, so we figured out how to store our data properly. We've picked our tool, we've put our objects in it, we're done, right? Not even close. Storing the data is just the beginning. Now we have to actually do something with it.
So imagine you've got an array list with all the marks from your class. They're all in there, but they're in a completely random order. How do you find out who's the class topper? How do you create a rank list? You've got to sort it. You have to bring some order to that chaos.
Well, the good news is the collections framework doesn't just help you store things. It gives you amazing tools to work with them too. And when it comes to sorting, Java makes it almost ridiculously easy.
I mean, just look at that. It's beautiful. There's this helper class called collections with an S, and it has one method you need to know: sort. You just give it your list, and that's it. It's sorted. No need to spend hours writing your own sorting algorithms.
And this is a really important piece of advice. The people who wrote these built-in algorithms are brilliant. They are highly optimized and super efficient. Seriously, trying to write your own is like trying to reinvent the wheel, except your wheel will probably be slower and a bit wobbly. Just use the tools they give you.
Okay, but this raises a huge question. Sorting numbers or strings? Easy.
The computer knows how to do that. But what if you have a list of your own custom student objects? How does Java have any idea if it should sort them by roll number, or by name, or by their marks? How does it know?
Well, the answer comes down to two very important interfaces. Understanding them is what separates the beginners from the pros. So let's have a little sorting showdown. Comparable versus comparator.
Here's the difference in a nutshell. Comparable is for the one single natural way to sort your object. You build this sorting logic directly inside your student class. It's like telling Java, hey, by default, students should always be sorted by their roll number. But what if you sometimes want to sort them by name or by their marks? That's what Comparator is for. It lets you define external, custom sorting rules. You can create a separate comparator for every single way you might want to sort your list.
So here's your game plan. Step 1, decide on the main default sorting logic for your class and implement comparable. Step 2, for any other way you want to sort it, create a new, separate class that implements comparator. Step 3, when it's time to sort, you can either call the simple sort method to use the default logic, or you can pass in one of your custom comparators to take control. It's powerful and it's flexible.
Whew. Okay, we have covered a ton of ground here. We've gone from the basic problems with arrays all the way to advanced custom sorting. So let's boil it all down to the key things you absolutely need to remember.
Think of this as your cheat sheet. If your data size might change, use collections, not arrays. If you need to keep things in order and duplicates are fine, use a list. If you need to make sure every item is unique, use a set. For that one main way to sort your objects, use comparable. For every other sorting rule you can think of, use comparator. That's it. That's the core of it.
So, the next time you sit down to write some code and you realize you need to store a group of objects, just pause. Think about what you really need. Because you have this entire toolbox now. Your data needs a home. The only question is, which collection are you going to build for it?